Hey, Miss Miklos here, and tonight our lecture is on hyperbolas. Oh wow, I totally forgot that I was on that. There we go. I actually promised you guys that we would have a little fight, so here we go. It's not that fun. Okay, anyways, there you go. There's the lightsaber for tonight. So our definition for a hyperbola is in a plane the set of all points such that the difference of the distances from the two foci is a constant. So our key word here is difference, where you guys may notice this is very similar to an ellipse. The difference is in ellipse it said sum. So for a hyperbola we have two different general formulas. Our first one is x minus h squared over a squared minus y minus k squared over b squared equals 1. And once again, we notice this is very similar to what we saw with ellipses, except we have a minus instead of addition. Our second version of this formula is very similar. The only difference is this time my y value is positive and my x value is negative. So we notice these general formulas very similar, okay? And we can already kind of see what makes something a hyperbola, and we will spend some time talking about that. The next thing we're going to talk about, though, is what do we need to know when we are graphing? So the characteristics that we need to write down are very similar to what we did for an ellipse. Our center is HK, and once again, those are coming from the opposite of the values that are inside the parentheses. Plus or minus a is the square root of our denominator for our x, and plus or minus b is the square root of our y denominator. Now, obviously, we know it's not going to be exactly the same as it was for an ellipse, so there are a few differences. The first one is we need to pay attention to which variable is positive. Okay, so if x is positive, so if it looks like this first general formula, that means we're going to graph it around the x-axis, and we know the x-axis goes right and left. If y is positive, then we're going to graph around the y-axis, and we know that the y-axis goes up and down. Okay, so this is one of the things we don't necessarily need to write out, but we definitely need to know. Now, the way that we're actually going to graph this, a hyperbola is going to look like two parabolas combined. And the first thing we're going to do is plot the center and the intercepts. So that's exactly what we did with an ellipse. However, once we get to that, instead of drawing an oval shape, I'm going to connect the intercepts with what we're going to call a box. Okay, and I think it's going to be easier when we actually see it, but we will see that this box is going to be dashed lines because they are not technically solutions. Then, the whole purpose of drawing this box is it is going to define what the asymptote should be. So I'm going to draw diagonals of the box, which would be our asymptotes. These are going to be the lines that define how fat or skinny our parabolas are going to be. Okay, so this will all make sense when we get into our first example. Now, our characteristics, we really have two things that make something a hyperbola. The first one is that both x and y are squared, and that really is what sets this apart from a parabola. And the second one is what makes this different from anything else, is that we have subtraction. So I either have x squared minus y squared, or we have y squared minus x squared. So that is the signal to me that we actually have a hyperbola. So let's get into number one here. Number one, I have 4x squared minus y squared equals 16. I can tell that this is a hyperbola because both variables are squared, but we have subtraction. We know we do not need to complete the square here because I don't have an extra x, I don't have an extra y. So what I'm going to do here, I'm going to begin by dividing everything by 16 because just like in our ellipse, I need to get this constant equal to 1. So I get x squared over 4 minus y squared over 16 equals 1. So our center here would be 0, 0. My x-intercepts are going to be plus or minus 2, and my y-intercepts are going to be plus or minus 4. So now I'm going to go ahead and graph this, and I'm just warning you guys, this might be kind of rough graphing on here. But I'm going to go to the right 2, to the left 2. I'm going to go up 4, and I'm going to go down 4. And I'm going to go ahead and sketch this rectangular box. So this is what I was talking about. And the whole purpose of this box was so I could draw these diagonals. Okay, so there we go. There are our diagonals. And once again, those are defining how wide our parabolas are going to be. Okay, so now I need to determine, am I going to graph to the right and left, or am I graphing up and down? I'm glad I can speak tonight. And if we look at this, we notice that x is positive. So this tells me that I need to graph around the x-axis. Okay, we know the x-axis is going to the right and left. So I notice that I actually have a point here and a point here. So I'm going to go ahead and start on that vertice. Okay, that is the vertex for our parabola. And then I'm drawing my parabolas so they get really close to this asymptotes, but they do not actually touch them. Okay? So, once again, we're finding our center and our intercepts the same way we did in an ellipse. Instead of drawing an oval, we drew this box. And once again, the reason why this box is dashed is because these are not actually solutions. The only solutions are on our solid portion of our hyperbola. Number 2, we can tell once again this is a hyperbola because I have x squared and y squared and we have subtraction. And I can tell once again I do not need to complete the square here because we do not have an extra x or y. But this looks weird because it said equal to 0. So I know that the very first thing that I have to do here is subtract 16. And now I'm going to divide all of these by negative 16. So I get negative x squared over 4 plus y squared over 16 is equal to 1. If we really wanted to, we could rewrite this so the y squared is first, but I would leave it like this. I think we can figure it out. So our center here is going to be 0, 0. Our x-intercepts are plus or minus 2. And my y-intercepts are plus or minus 4. Okay, so we might be thinking this is exactly the same as our last hyperbola. However, this time I notice that it is my y that is positive. So I know that I'm going to have to graph this around the y-axis. Okay, so I'm starting at 0, 0. I'm going to the right 2, to the left 2. Up 4, down 4. And I'm going to go ahead and sketch this little box out. Okay, and once again, the whole purpose of drawing the box is because it is going to define where the asymptotes would be. And I think we can kind of see that the shape of this box really determines where these diagonals are. If the box was more this way, our diagonals would not be as vertical, they would be more horizontal. Okay, so this time I'm going to go to my vertex, which we already plotted, and I'm going to draw a parabola that is going up. And I'm going to go to my other vertex, which I plotted, and draw a parabola going down. So once again, we're noticing a hyperbola is really just two parabolas combined. Okay, number 3, once again, I say that they're both squared. And this is one that if we make a judgment too quickly, we may not think that it is a hyperbola. Because right now I don't see subtraction. However, I also do not see my square terms on the same side. So just so you guys know, the first thing I should always do is get my square terms on the same side before I determine what it is. Now I can see that they're on the same side and we have subtraction. I'm going to go ahead and divide everything by 9. So I get y squared over 9 minus x squared over 1 equals 1. So my center is going to be 0, 0. My x-intercepts are going to be plus or minus 1, and my y-intercepts are going to be plus or minus 3. Okay, I also notice that the y-axis is going to be where we're graphing because y is our positive variable here. So I'm starting at 0, 0. I'm going to the right one, to the left one, up 3 and down 3. And I'm going to go ahead and graph this. There are my diagonals. There we go. Sorry if you can hear Milo in the background. He's meowing a lot. I don't know why. Okay, so we said this is going up and down, so I'm going to go ahead and plot my parabola going up, and I'm going to also plot my parabola going down. The majority of our ones on our homework tonight are going to be kind of at this level of difficulty. So the key thing is for me to be able to recognize that it is a hyperbola and know how to create this box, the asymptotes, and know how to graph. Okay, number 4, in my opinion, is actually easier, but it looks harder because we can see our center is not 0, 0. The reason why I think this one's actually easier is because it's already in the correct form. So we can figure out this time my center is at 2, 1. Our x-intercepts are plus or minus 3. And our y-intercepts are plus or minus 2. I also notice that the x variable is positive, so I'm going to be graphing this on the x-axis. So I'm going to start at 2, 1, and I'm going out 1, 2, 3, 1, 2, 3. I'm going to go up 1, 2, and down 1, 2. And we're drawing our box here. Okay. It's tough when my dots are not perfect. And here are the diagonals, which are the asymptotes. We said we are graphing the x-axis. That means I'm graphing a parabola to the right, and I'm graphing a parabola to the left. I want to point out one last time here. Notice I used these points as the vertices. If you're just making a parabola float in space somewhere, you will get marked off. So let's step it up a little bit here. Number 5, once again, I can definitely see that this is a hyperbola because, here we go, we'll have a hand this time. I have a y squared and I have an x squared, and we have subtraction. But what I also notice is that I have this extra 4x, so I know that I need to do something about it. So what I'm going to do here, I'm going to go ahead and group my negative x squared and my 4x together. Now, as we've learned previously, whenever I have a leading coefficient other than 1, I need to factor that out. So I'm going to do y squared minus, and this is then going to become x squared minus 4x. So that's why I wanted to make sure to put a plus out here, because otherwise it's really easy for me to forget to take a negative out of that middle term as well. Now when I complete the square, negative 4 divided by 2 is negative 2, and squaring that I get 4. However, when I balance this, negative times 4 is negative 4, so that's what I have to add to the other side. So I get y squared minus x minus 2 squared equals 9. When I divide everything by 9, I get y squared over 9 minus the quantity x minus 2 squared over 9 equals 1. So our center would be 2, 0. My x-intercepts are plus or minus 3, and the y-intercept would be plus or minus 3. And I notice that I need to graph this on the y-axis because y is positive. Now the reason my center was 2, 0 instead of 0, 2 is because I noticed that this negative 2 corresponded with my x value. So I always need to be paying attention to what is in my parentheses. So now when I'm graphing this, I'm starting at 2, 0. I'm going to the right 3, to the left 3, up 3, and down 3. So you guys might notice that this time our box is actually a square. Okay, so I'm plotting my diagonals there. Since it's the y-axis, that means up and down, so I'm going to graph a parabola going up, and I'm going to graph a parabola going down. So, you guys are probably seeing the repetition here. We're doing a lot of the same things again and again and again. Looking at number 6, what makes this one a little bit different is I have an inequality symbol. So we just need to kind of think back, and I know this inequality symbol is telling me it's either going to be solid or dashed, and I'm going to have to shade somewhere. Okay, so otherwise I'm going to treat it the same, and I'm going to start by dividing by 4. So I get y squared over 4 minus x squared over 4 is less than or equal to 1. Just a note to make sure we're aware of, if I ever divide by a negative, I need to flip my inequality symbols. My center here is going to be 0, 0. My x-intercept is plus or minus 2. My y-intercept is plus or minus 2. I also notice that since it says less than or equal to, that my graph should be solid. Finally, I know I'm graphing this over the y-axis. And I really shouldn't say finally, because our final thing, we know we're going to have to shade. And we're going to talk about that after I plot this. Okay, so I'm starting at 0, 0, and I'm going to go out 2 in all directions. And I'm going to go ahead and graph that box so I can graph the asymptotes. And notice, even though we said that it's going to be solid due to the inequality symbol, all of this is still dashed. What is going to be solid here is going to be my parabola that's going up and my parabola that's going down. So at this point, we really have 2 places where we could shade. We could shade in between here or shade it inside both parabolas. So like every other problem this chapter, when we're shading, I want to substitute in the center. Okay, so I'm going to try 0, 0. And if I try that, I get 0 minus 0 is less than or equal to 1, which is a true statement. Okay, so what that means for me is that I'm going to have to go ahead and shade. Okay, and I'm making this big here. I'm going to shade everything that is in between, okay, where the 0, 0 is. So this tells me that everything in here is a true statement and would make this inequality true. That is the only thing that we're doing different here when we have an inequality symbol. Number 7, I noticed that we have this square root. Okay, so I may remember when I have x equals negative square root, that means that I am only graphing to the left. And I want to make a big note of that because that's definitely going to impact what I graph. Now, if I look back here, I really cannot tell what type of conic section this is until I square both sides. When I square x, I get x squared. And when I square negative, I know it becomes positive. And the square root of y squared plus 4 becomes just y squared plus 4. I know that I need to get my squared terms on the same side before I determine what it is. And now I can tell that this definitely is a hyperbola because I have subtraction. So I'm going to divide by 4 and I get x squared over 4 minus y squared over 4 equals 1. So my center is going to be 0, 0. My x-intercept is plus or minus 2. My y-intercept is plus or minus 2. And since x is positive, we know we're graphing around the x-axis. Okay, so I'm starting at 0, 0, and I'm going out 2 in all directions. So for the 7th time tonight, I am drawing this box. And then I'm drawing my asymptotes. And I really need to think this time because we wrote ourselves a note. Not only am I doing the x-axis, but we said only the left side. So that means I'm only graphing a parabola to the left. If I really wanted to, I could graph a dashed parabola to the right just to show that I understand that, but I definitely do not need to do that. If you guys just gave me what is on the left, you would get full credit. And hooray, last but not least, we have number 8. And you guys are probably thinking, what the heck is going on here? And this is what we call a special hyperbola. And if I didn't know it was a hyperbola, there's really no way of seeing that because we don't have anything squared. Okay, but on a special hyperbola, it's actually going to be easier to work with than our normal one. Our asymptotes are going to be the x-axis and the y-axis. Okay, so actually right away here, I'm going to go ahead and graph that those are the asymptotes. Now, the reason why this makes life easier for me is because the whole purpose in drawing our box and our diagonals was so that we could figure out where the asymptotes are. Here, okay, I know that they are the x-axis and the y-axis, so we are set. Now I just need to figure out where the heck to graph it. So, if we think back to previous chapters, whenever I didn't know how to do something, I could always make an XY chart. I know that whatever I put in here has to have a product of 9. And so the best way to start off is I'm actually going to take the square root of 9, which we know is 3, and I'm going to have a point at 3, 3, and at -3, -3. And just to double check, 3 times 3 is 9. -3 times -3 is also 9. So I'm going to go 1, 2, 3, 1, 2, 3, and go -3, -3. Now, if I was being really technical, there would also be points of 9, 1, and 1, 9, and 2, 4.5, and 4.5, 2. And we would kind of see that it would cause a parabola that looks something like this. Now, I honestly don't care if you guys give me all these additional points that multiply up to be 9. If you just give me this, and then go ahead and draw that it's getting close to the x-axis but not actually touching it, I would be totally fine with that. So just kind of to review, if we had xy equals 16, that means that my points, my vertices would be at 4, 4, and at -4, -4. If I had xy equals -4, it would be at 2, -2, and -2, +2. Okay, so hopefully you guys are kind of seeing the pattern, and this is a special case, but I would definitely expect to see one like this on our test. So hopefully we're feeling pretty good on hyperbolas. Once again, I know something is a hyperbola if they're both squared and we have subtraction. And so have a great rest of the night. Good luck on your homework and do your best.